Good day. Today we are going to do improper integration. So before you do improper integration, you need to have a bit, or you need to understand proper integration. So I'm not going to do proper integration today. I'm going to focus on improper integration. So if it happens that you need a video on proper integration, make sure you subscribe, you hit the notification button, and comment proper integration. So now let's start. Improper integration, the definition. We need to understand the definition. It says that the integration from A to B of f of x in respect of dx. This one is called improper. It is called improper integral. If, Roman figure 1, if a is equal to negative infinity or b is equal to infinity or both, meaning that both a and b are infinite. Then number 2, if f of x is unbounded, it is unbounded on a and b, and these two or these a and b are known as singularities of f of x. So now we need to look at the first kind of improper integration, which it is type 1. So any integral of any given function, if it satisfies one of the two conditions here, then it is called improper integration. So we have the first type, which is type 1. This one, it says that if, number 8, if the integral from negative infinity to t of f of x in respect of dx for all t greater or equal to what? Negative infinity, or negative, I think here's a, I'm sorry, for all t less or equal to a, where here we can substitute t, not negative infinity. I'm sorry about that. If the integral from t to a of f of x in respect of d of x for all t less or equal to a, so to avoid confusion, let me use b instead of a. You will notice why. And then if we have this, then the integral from negative infinity to b of f of x in respect of dx will be equal to the limit as t approaches what? Negative infinity into the integral from where there is negative infinity on this one, we are going to substitute t. And then here we have b, and then we have f of x dx. Provided the limit exists. So note that if the limit exists, if the limit as t approaches negative infinity into the integral from t to b of f of x in respect of x exists, then the integral from where? From negative infinity up to b of f of x in respect of dx converges. So we need to apply this type 1. As an example from this type 1, example, we need to check number 1. We're going to say check if the following converges or not. Then I have this one. Then from negative infinity, I have the integral from negative infinity up to minus 1 d of x. I have x squared minus x. And then you need to check. The first step, you check if it is proper or improper. From here, we've noticed that the integral of f of x from certain point to another point is called improper if one of the two conditions are satisfied. So if we check here, we can write this in the form of negative infinity up to minus 1, including minus 1, excluding negative infinity, where we can see it corresponds to this one where a is minus negative infinity. That's why I said here, allow me to use b instead of a. So now, since we know that it is improper, then we are going to apply this type 1 and the first property, or property number a, where we have to apply this. And then the integral, this is the solution. The integral from where? From negative infinity up to minus 1 d of x divided by x squared minus x, it is equal to, by following this, we have to introduce the limit. It is equal to the limit as t approaches negative infinity into the integral. Where there was negative infinity, we substitute t up to minus 1. Then allow me to write this in the form of 1. Then take out the common factor of x. We are left with x minus 1 from here. And then here we'll have dx. And then, if we can check, this is what we call a partial fraction. And then I need to simplify this so that I'll be able to integrate. Then, since it is partial fraction, which it is this one, x minus 1, this will be equal to a divided by, we see equal x, we have the product of two linear equations. Then we are going to divide them into a divided by x, because now we don't know the value of a. Then we're going to say plus b, and also x minus 1, it is a linear equation, that's why I have b, x minus 1. So please take note that if it was quadratic, you're going to have bx plus c. It's like on the numerator, you need the derivative of what you have on the denominator. And then now, we can easily see, here we have 1 into x minus 1, into here we have x, when we multiply x minus 1, divided by, we'll have a, and then this divided by this will cancel x, and then we are left with a times x minus 1 plus, the same applies to this one of b. We have b into this divided by this, you will be left with x, then we have x. So since the denominator of the one on the left is the same as the denominator of the one on the right, we are going to drop them. You are left with 1 equal to a into x minus 1 plus b into x. And then now we need to determine the value of a and b. So in order to determine the value of a and b, you need to go back here and check. First, I will determine the value of a. To determine the value of a, since I want this value, I will go to this one and check where x is undefined. We know this will be undefined when x it is equal to 1, because you will have 1 minus 1, then we'll have 0. Division by 0 is undefined. We all know that. So you are going to let x to be equal to 1. And then when x is equal to 1, on the left you have 1 into a. When there is x here, you substitute 1 minus 1, and then plus. b into 1. And then now you see, okay, a will be 0. Then 1 will be equal to a into 0 plus b. b times 1 is b. Then we can easily see b is equal to 1 from here. Therefore, b divided by x minus 1, it is the same as 1 over x minus 1. But we're not done. We only got the value of b. And now we want the value of a. To find the value of a, we will check where these will be undefined. And it will be undefined when x is 0. Because here you only have x. And division by 0 is undefined. So now you're going to say let x to be equal to 0. And then here from this, you have 1 equal to a multiplied by 0 minus 1 plus b into 0. And then here we can easily see that we have a into minus 1 plus 0. b times 0 will be 0. And then here we can easily see that minus a, it is equal to 1. Since we want the value of a, not minus a, we are going to divide by minus 1. Then a is minus 1. Therefore, we can easily see from here that a divided by x is equal to minus 1 over x. And then now, since we saw, in conclusion, we can say that 1 divided by x into x minus 1 is equal to the value of a is minus 1 over x. Minus 1 over x plus that one of b is 1 divided by x minus 1. So now we can go back to our integration here. And then we're going to say, okay, the integration from negative infinity to minus 1 of the integral was d of x into x squared minus x. This is equal to the limit as t approaches negative infinity into the integral from t to minus 1 of what? Of this. Since we know this is equal to this. Now we're going to say, okay, here's minus, here's positive. Let me start with this one of positive x minus 1. Then we will have minus 1 over x all in all in respect of dx. And then now, first, I can integrate this one and leave this one, or integrate it after. I can integrate them one by one. Okay, we know that the integration of 1 over x minus 1, since this one, the derivative of this one is this one, we know that the integration will give us ln of x minus 1. And then which means we'll have the limit as t approaches negative infinity into ln of x minus 1. From where? From t to minus 1. When we integrate this one. And then now it will be equal to what? We start from minus 1. We have the limit as t approaches negative infinity of ln of 1. Oh, it's minus 1 minus 1, which will give us minus 2 minus the limit as t approaches negative infinity of ln of, now we have t minus 1. And then now the limit as t approaches negative infinity into ln of minus 2 minus the limit as t approaches negative infinity into ln of t minus 1. As t approaches negative infinity, then this will be equal to, then the ln of minus 2, we can easily see it's what? The ln of minus 2. So this, the limit of this, you see ln of the absolute value of minus 2 is a constant. Then this will give us ln of 2 minus the limit as t approaches negative infinity of this one will give us infinity. And here, ln of 2 minus infinity will give us negative infinity. So, since the integral of this from negative infinity to 1 d of x divided by x squared minus x give us negative infinity, then we can conclude that it converges. I mean it diverges, since we have these two, then the integral from minus negative infinity to 1 of d of x divided by x squared minus x in respect of dx diverges. So there's no need to determine the integral of minus 1 over x, even if we find it to be converging, that because of this it will be affected, and then it will diverge. So we've seen the first example, and the first example was corresponding to type 1 and property A. Now we need to check property B, which says that if, remember, if we can check property A, it was from T to B, and then now we will have if the integral from A to T of f of x in respect of dx for all t greater or equal to what? A. If you can remember here, it was for all t less or equal to B, and B was here above. But in this case, there's t above, and here we have A. That's why we say these must be greater or equal to this one. So now, then, this is property B of type 1. Then the integral from from negative infinity, from A up to infinity of f of x in respect of dx is given by the limit as t approaches. Now we are approaching infinity, while here we are approaching negative infinity. So now we approach infinity. It's like the inverse of A. So now it will be the integral from A, where there was infinity, we substitute t, of f of x respect in dx, provided the limit exists. The limit exists. So please note that if the limit as t approaches infinity into the integral from a up to t of f of x in respect of x exists, then the integral of this one from a up to infinity of f of x in respect of dx converges. Otherwise, it diverges. So you'll finish for me. Example. We need to apply property B. We are going to check the example. It continues from the first example from property A. Example. The question was to check if the following integrals converges or diverges. Now I'm doing B. We have the integral from 0 up to infinity of 1 divided by 1 plus x squared in respect of dx. So first, if we have to write the interval of this, we can see that we include 0 and we exclude infinity. That's the first step. And you ask yourself, from the definition of improper, it says that b must be equal to infinity in order for the integral to be improper. But in this case, if we have to name them, we see where a is 0, but b is infinity. This tells you that it is improper integral. And then we need to apply type 1 and property B under type 1. We say that if you have something like this, then you will have this. I'm going to apply this where I introduce the limit, which means I can write this as the integral from 0 up to infinity of 1 divided by 1 plus x squared dx to be equal to, from here, from property B under type 1, we know that it will be equal to the limit as t approaches infinity into the integral from a to t, but in this case our a is 0, and t, now where there was infinity we substitute t, and our f of x is 1 divided by 1 plus x squared, then in respect of d of x. So check here, this one, you can't use substitution, or maybe others can use substitution, but I already know that the integral of, or I can say that the derivative of, in respect of d of x, of tan inverse of x, it is equal to 1 divided by 1 plus x squared. But in this case, we are not given the derivative. We are given the integral, which is the reverse. So if we are given this, then it means that its integral will be this one, and the derivative of this one will be this one. So I know that the limit as t approaches infinity, then since I know the integral of this, I'm going to substitute the integral, which is what? Tan inverse of x, since here the coefficient of x squared is x. So please take note that if here it was 2 and here it was 2, you are going to have 2x from 0 up to t. So some might like to use arc tan x. It is the same. So now this will be equal to the limit as t approaches infinity. We substitute the tan, where there is x, we substitute t, minus the limit as t approaches infinity of tan inverse of 0. But this one we already know that it is 0. So now we need to determine the limit as t approaches what? So now we need to find the limit of this. Let's take a look at the graph of tan. The graph of tan, it is said to oscillate between negative infinity over 2 and, pi over 2 and pi over 2. So about negative infinity over 2 is pi over 2. So now we see that this tan inverse, as it approaches infinity, here it will be this side. As it approaches infinity, it also approaches pi over 2, which means that this limit will be equal to pi over 2 minus 0. And then this will be equal to what? Pi over 2. That's the limit. So since we got the limit as pi over 2, we can conclude that we can say, since the limit as t approaches infinity of the integral from 0 up to t of 1 divided by 1 plus x squared in respect of dx is equal to pi over 2, then it means that the integral from 0 up to infinity of 1 divided by 1 plus x squared in respect of dx converges. Remember, the limit exists. As I said, if it exists, then it converges. Then we are going to say converges to what? To pi over 2. Thank you.